everyone, thank you so much for joining me today. We are looking at maths and we are going to be looking at some of the questions that you guys would have practiced in calculus and perhaps questions that you at home had some problems with. So we're going to be going through some questions that you really obviously need for exam, but also some of the common mistakes that occur when we go through practicing questions, especially when we're doing some exam revision and looking at past papers. Okay, so let's look at question 1. So in this question, we are given a graph that's drawn, as you can see, and we are asked to show that the equation of the graph is given by f of x is equal to negative x cubed minus 3x squared plus 9x plus 27. So we can see straight away that we are asked to show that a is less than 0 firstly, but in fact a is equal to negative 1. Okay, a being the coefficient of x cubed. We can also see that the y-intercept is 27, which is given to you on the graph. And we need to find the whole equation multiplied out, giving us that the b term is minus 3x squared. So the coefficient b is minus 3, and then c is 9. So where am I getting those a, b, c, d values from? Well, the fact that f of x is equal to ax cubed plus bx squared plus cx plus d. So another way we could ask this question is to say, well, show that a is equal to negative 1, b is equal to negative 3, c is equal to 9, and d is equal to positive 27. So let's have a look at the graph and what we are given. We see that we have the turning points, minus 3 and 0, so the x coordinate is minus 3, the y value is 0, and then the other turning point is 1 and 32, x value 1 and y value 32. How do we find the equation of this graph? Well, very simply, what you need to remember is that when you are given the x-intercepts, which in this case you are, we've got x-intercepts here, 3 and 0, and then the turning point being one of the x-intercepts, that occurs twice. So when you're given the x-intercept, we're going to use f of x is equal to a times x minus the first intercept, x-intercept, times x minus the second x-intercept, times x minus the third x-intercept. Now guys, when you have a graph that we have here, where the turning point is actually an x-intercept, you will substitute x1 and x2 with the same value because it occurs twice. All right, you'll see what I mean when we do the question. So this, by substituting in, will help us to find the value of a, which we can then use to find the values of b, c, and d. All right, so we're going to say a times x minus x1. So we saw that the x-intercept at this point is minus 3. So I substitute x minus 3. And it's so important that you use brackets, because remember, brackets prevent you from making silly sign mistakes. So it's going to be x times x minus 3 times x minus 3. Why am I repeating it? You will see that whenever you have an x-intercept that is also a turning point, that value occurs twice as an x-intercept. Okay, you can prove it for yourself by doing lots and lots of questions, but that is in fact what always happens. All right, and then we substitute the other turning point, the other x-intercept, which is x minus, it's positive 3, but we'll put it in brackets just to be consistent. All right, so we end up with a times x plus 3 squared times x minus 3. And then we think, okay, that's great, but now how do we go and find the value of a? That's when you've got to go back to your graph that they've drawn for you and see what other information they've given you. So they've given you the y-intercept and they've given you the other turning point. So they've given you the maximum turning point and they've given you the minimum turning point. You can choose either of those points, either the turning point or the y-intercept, to help you find the value of a. So what do? We substitute one of those. So I'm going to use the, let's just go back there. I'm going to use, and we're going to go one back, I'm going to use 0 and 27, so that's the y-intercept, to help me find the y value, the a value. So we're going to substitute x is 0, y is 27, and that will help us find a. So f of x is equal to 27 times a. I choose not to multiply these brackets out. You can if you want to, but you're more likely to make mistakes if you go and square this out and multiply by x minus 3. You're more likely to make mistakes than if you just substitute your x value straight in. So I'm going to have 0 plus 3 squared. So where there was an x value, I substitute the x coordinate. And I end up with 3 squared, which is 9. 9 times negative 3 is negative 27. What happens to the 0? Well, 0 minus 3 is just going to give me minus 3. So we end up with minus 27a is equal to 27. Now swap the equation around, and that's perfectly okay. We divide both sides by negative 27. And so we've shown that a is equal to negative 1. Okay, so that's great. Now that we've got the value of a, though, how do we get the values for b, c, and d? So all you're going to do now is take your value for a, substitute that back into your f of x equation where you've already substituted your x-intercepts. So what I'm saying, if you have a look here, we're going to take the value of a is equal to negative 1, substitute it into this line. All right, so substitute a is equal to negative 1 there, and then multiply out. Okay, so let's do that. So I'm going to get f of x is equal to negative 1, I substitute the value of a in, times x plus 3 squared times x minus 3. Okay, so we get minus 1 times x squared plus 6x plus 9. And all I've done to get that bracket is I've taken x plus 3 squared and I've squared the binomial. So I've multiplied x plus 3 by x plus 3, and that gives me x squared plus 6x plus 9 times x minus 3. Now some of you may choose at this point to times the minus into the bracket. There's nothing wrong with that. I think though that leads to more room for errors where we can make sign mistakes. So what I prefer to do is to keep the minus until the end and then multiply it through. So what I would do is I'd keep the minus here outside, the minus 1, and let's times these two brackets out. Okay, so x times x squared will give me x cubed. All right, and all I'm doing here, let me just get a different color and I'll show you what I'm doing. I'm taking the x value, multiplying by each term inside the bracket, and then I'm going to do the same thing with the minus 3. Multiply it to each term in the first bracket. All right, so we've got, let's go back to our red, we've got x cubed plus 6x squared plus 9x, and in fact my bracket needs to be a little bit bigger. All right. So I've got x cubed plus 6x squared plus 9x times the minus 3 minus 3x squared minus 18x minus 27. I've just times through by the minus 3. Now when we get to that point, all we do is multiply the minus through the brackets after we have added our like terms. So first collect your like terms within the bracket and then multiply by minus 1. So x cubed stays the same. 6x squared minus 3x squared gives me plus positive 3x squared. 9x minus 18x will give me negative 9x. Minus 27 comes down with the same sign. And then we multiply the negative 1 through the brackets. Okay, obviously when you multiply the negative through, now is when all your signs are going to change. So we end up with f of x is sorry, let's go back there. F of x is equal to negative x cubed minus 3x squared plus 9x plus 27. All right, so we go back and look at what they said. They said show that A is -1, we've done that. B is -3, C is 9, and D is 27. So if we go back to the first part of the question where they said to us, show that the equation is f of x is equal to negative x cubed minus 3x squared plus 9x plus 27. When we compare those coefficients to what was, we compare what was given to you to what we found, we see that they all match up, and that makes us very happy because it means we've got full marks for this question. So finding the equation of cubic graphs is an important part of your calculus cubic functions. Do not only concentrate on sketching cubic functions. Yes, that's extremely important, but remember to also focus your study time on finding the equation of a cubic function. How do we find the cubic equation? It can differ depending on what the question says and what's given to you, but in the case where you've got 3 x-intercepts, as you saw in our graph, because the turning point was also an x-intercept, it is a squared bracket, but once you are given the x-intercepts of your cubic function, you will use that formula f of x is equal to a times x minus the first intercept times x minus the second intercept times x minus the third intercept, and then substitute a value of the point you've been given to help you find the value of a. Okay, but you will do many practice questions on finding the equation of a function. I hope you will do many practice questions to see all the different ways that this question can be asked. All right, guys, I think it's time for us to take a quick break. When we come back, we will carry on with cubic functions. Hi guys, welcome back. We are looking at consolidating your knowledge of calculus, and we are looking at some of the questions that you would have tried and maybe you would have had some problems with. We're also looking at some of the common mistakes that you need to be looking out for to make sure that you don't make those same mistakes when it comes to exam time. All right, so this is now question 2. We're continuing with calculus functions. This is now a graph interpretation question. All right. So here we are given the graphs of f of x is equal to 4x plus 2. We see that that's a straight line. And then we've got the cubic function g of x is equal to x cubed plus x squared minus x minus 1. As you can see, those two graphs are drawn for you. We quickly can analyze this graph before we look at what the questions say. We see that d is the x-intercept of the straight line. F will be the y-intercept. The point B is the maximum turning point or your relative maximum of the cubic function. The point E is the relative minimum of the cubic function. A is the x-intercept of the cubic function, and C is the y-intercept of the cubic function. All right, so let's see what the question says. The first question says, determine the length of DA. So if we go back to the diagram and I look at this length DA, we've already said, well, D is the x-intercept of the straight line graph, f of x, and A is the x-intercept of the cubic function, g of x. So how do I find this distance dA? Well, it's a horizontal distance, so it's simply going to be the difference between the two x values. So what that tells me is that I need to find the x-intercept of the cubic function, and I need to find the x-intercept of the straight line, and then only will I be able to find the distance dA. Okay, so we've analyzed the graph, we've seen what the point D is, and we see what the point A is, and therefore we have an idea now that if I'm looking for this horizontal dA length, I need to then find the two x-intercepts that are relevant to this part of the question, and then we're going to find the difference between them to find the length dA. Okay, so let's start with finding the x-intercept of the straight line f of x is equal to 4x plus 2. So to find the x-intercept, you say let y equals 0, because obviously this is a point on the x-axis, so all my y values will be 0. So therefore we say let y equal 0, so I get 4x plus 2 is equal to 0, so therefore x will be equal to, what do? We take the 2 over to the right-hand side, it becomes minus 2, and I divide both sides by 4. So if I have 4x is equal to minus 2, I'm going to divide both sides by 4, and I will get that x is equal to minus a half. So what does that mean? It means that the coordinates at point D are negative a half and 0. So if we go back to the graph, if this point D is minus a half and 0, that means the length from D to the origin would be half a unit. How do I get that? Well, remember at the origin your coordinates are 0, 0. So 0, the x value, minus a half will give me that length D to O. So the length from D to O is a half a unit. All right, so if we zoomed in there, we could see which length we are talking about. So that length is a half a unit. Now I need to find the length from 0 to A, the origin 0 to A. So we saw that the cubic function is given by f of x is equal to x cubed plus x squared minus x minus 1. Now, you will see this cubic function, and straight away you'll think, well, the way I should solve this equation and find the x-intercept is by using the remainder and factor theorem. I use the factor theorem here. You'd be absolutely correct. Yes, you can use the factor theorem here, but there's a quicker way to do this one. So we can factorize this with the factor theorem, or we can factorize this by grouping. I'm going to go for grouping because it just jumps out at me. That's what I can see first. If you see the factor theorem first, then go for that. Okay, so I'm going to group this. Again, I'm finding the x-intercept. So I'm going to say let y equals 0. So I get x cubed plus x squared minus x minus 1 is equal to 0. So why did I say grouping? I can see straight away that if I group the first two terms and the second two terms, I'm going to get a common bracket. So if I group the first two terms, I can take out a common factor of x squared, and that will give me x plus 1, because I divide each term by x. So x cubed divided by x squared is x squared divided by x squared is 1. From the third and fourth term, I'll take minus 1 out as a common factor, and I divide through by the minus 1, so minus x divided by minus 1 gives me x, minus 1 divided by minus 1 gives me plus 1. And as you can see here, you now have a common bracket. So we pull that common bracket out as a common factor, and we get x plus 1 times x squared minus 1 is equal to 0. So therefore, if we let each bracket equal 0, we get x is equal to negative 1 from the first bracket. Or we're going to say x squared minus 1 is equal to 0. So you can factorize that doing difference of squares and then solve. Or we can say x squared is equal to 1. Therefore, x is equal to plus or minus the square root of 1, which would just be plus or minus 1. Okay, so now that we've got the x-intercepts, minus 1 and also plus or minus 1, we're going to go back to the diagram and see which one makes the most sense for the coordinates of A. So one of my x-intercepts is going to be minus 1. We saw that, if you look at that, you see that minus 1 was a solution twice. Do you see that? So therefore, since we have an x-intercept that occurs twice, that tells me that that x-intercept is also a turning point. And certainly on the diagram, you can see that the point B is a turning point. So therefore, the minus 1 coordinate would go there, and the +1 coordinate would go there. And of course, just by looking at the signs, we've got our positive x values on the right, your negative x values on the left. So the coordinates at A are the point 1, 0. So therefore, the length from the point, the origin, to A is going to be 1 unit. So the total distance from D to A is 1 plus a half, which is 1.5 units. So dA is 1.5 units. Okay, another way you could think of it is you could say the x value at point A, which is 1, minus the x coordinate at point D, which is minus a half, and you would get 1 plus a half, because a minus times a minus is a plus, and that once again gives me 1.5 units. So whichever way you do it, you would end up with the value of that distance, dA, being 1.5. All right, hopefully you all understand that, an important concept, finding and interpreting values from what they've drawn for you on a graph. Okay, let's have a look at the next question. The next one says, find the values of x for which the gradients of f of x and g of x are equal. So we're looking for where the gradient of the straight line, which is 4, remember this is in the form y is equal to mx plus 4, where the gradient of the straight line will be the same as the gradient of your cubic function. So where are they going to be the same is not really important. They just want to know what is the x value when this happens. So all you're going to do is find the gradient of the cubic function g of x, equate it to the gradient of the straight line, and solve for x. Let's quickly do that on the screen. So we'll get the gradient of g of x is equal to 3x squared plus 2x minus 1. And we want to know where that gradient is equal to 4. So we equate those two, and we're going to solve for x. So we get 3x squared plus 2x minus 5 is equal to 0. Factorize those two, so we get 3x and 5, and then we've got x and 1. 3x plus 5 and x minus 1 is equal to 0. So therefore, at the points, x is equal to 1 and x is equal to minus 5 over 3. Those are the points where the x values are going to give you the same gradient for the straight line and the same gradient for the cubic function. You can test it and make sure for yourselves that it does give you the same gradient of 4. Guys, thank you so much for joining me on today's lesson. I hope that you have lots of questions, and you're going to send those questions to us as you practice, and we will answer more of your practice questions the next time.